Okay, here we go. All right, we are on number 21, which is m squared plus 8m plus 16 equals 0. I'm going to factor this if I can. So what I'm going to do is look for a GCF, and I don't see one. I'm going to look for special cases. Is this a PST? Well, that stands for perfect square trinomial. It's a trinomial. M squared is a perfect square, and 16 is perfect square. If I take half of b, which is 4, and square it, I get 16. Hey, this is a PST. And I know that when I factor a PST, I get a binomial squared. And what I'm going to do is take the square root of m squared, the sign of the middle term, and the square root of 16, and square it. This is my binomial squared that equals this PST, and that equals 0. Now, it's completely factored. We have to solve it. So I need to take every factor that contains a variable and set it equal to 0. Well, technically, m plus 4 quantity squared means this. So if I take every factor and set it equal to 0, what's going to happen is I'm going to get the same answer twice. Well, all that means is this particular quadratic only has one solution, and that solution, or that x-intercept, is -4. So if I were to graph this, its x-intercept would be -4. And since it only has one, that would be the vertex, and this parabola would open up from this point. It would have a y-intercept of +16, which would be like way up here. So this is going to be like this big old skinny guy that comes up like this. Opens up, leading coefficient's positive, y-intercept is 16, x-intercept is -4, and since it's the only point that touches the x-axis, it's also the vertex. Very cool. And if it was a PST, so we could instantly, boom, know to do a binomial squared when we factored it. Number 22, b squared minus 1 equals 0. That's kind of odd looking, isn't it? Does it have a GCF? Nope. Is it a special case? Well, I know it's not a PST because it's not a trinomial. Is it dots? Let's see, dots. Difference of two squares. Subtraction means difference. Two squares. B squared is a squared term, and 1 is a squared term, because 1 times 1 is 1. So guess what? This is dots. So if I'm going to factor dots, it's going to be SAD, which stands for sum and difference, and it still equals 0. Sum and difference of what? The square root of b squared is b. The square root of 1 is 1. So b plus 1 times the quantity b minus 1 equals 0. It's completely factored now, but I'm going to solve it. So I'm going to set each factor containing a variable equal to 0. That's my zero product property. I'm going to isolate my variable to 1. b equals -1, b equals 1. So if I graph this parabola, this would be one root, this would be another root. -1, that's my c value, so that's actually my y-intercept, and it's my vertex because it's exactly halfway between these two. So I guess my parabola is going to look something like that. Sweet. Number 23. M squared plus 8m plus 16 equals 0. I'm going to factor it. I don't see a GCF. Is it a special case? m squared is a square number, 16 is a square number, maybe it's a PST. It's a trinomial, these are both perfect squares. Take this term, half of it's 4, square 4, you get 16. Hot diggity dog, it's a PST, and when I factor it, I get a binomial squared. What's my binomial? The square root of m squared is m, the sign of the middle term is positive, and the square root of 16 is 4. Woohoo! M plus 4 times m plus 4 equals 0. M plus 4 equals 0. M plus 4 equals 0. What the heck? I did this one already. I'm supposed to be doing number 23, huh? Sorry. What should be added to both sides to complete the square? When you complete the square, you're supposed to put it in standard form and then get rid of c. Well, if I put this in standard form, I'd add 10 to both sides. I'll show you. Okay, now it's in standard form, but if I want to complete the square, I got to get rid of c. So I'm going to subtract 10. So look what happened. This is the equation we had at the very beginning, isn't it? So I didn't have to put it in standard form and then get rid of c, because they'd already gotten rid of c for me up here. But either way, now I need to force this to become a PST. So the way I do that is I need to get a new c. The way I get a new c is to take b, divide it by 2, and square it. So b is -8. -8 divided by 2 is -4. And if I square -4, I get 16. So I'm going to add 16 here, but I just changed the value of this side of the equation, so I better add it over here as well. What did I just do here? I forced this to become a PST. And how do you factor a PST? A binomial squared. Square root of x squared is x. Take the sign in the middle term. Square root of 16 is 4. On the right side, if I have 10 negatives and 16 positives, that equals 6. Now, I want to get rid of this exponent. The inverse of squaring something is taking its square root. If I do it to this side, I have to do it to this side. This radical sign cancels out my exponent, and I'm left with x minus 4. And over here, 6 does not have a nice tidy square root, so we're just going to call it plus or minus the square root of 6. I still have to isolate my variable, so I'm going to add 4 to both sides. These cancel out, and I get x equals, bring this down first, 4 plus or minus the square root of 6. Now, if they want to see the two answers separately, then you could say x equals 4 plus the square root of 6, and the other solution is 4 minus the square root of 6. And if we had to graph that, we'd have to take our calculator, find the square root of 6, which is only going to be an estimate because 6 is irrational, and then we would add it to 4, and that would be our root. And here we would take the square root of 6 and subtract it from 4, and that would be our other root. Okay, last problem for this video is number 24, and it says solve by completing the square. Okay, this is already in standard form. It's not a PST because 35 isn't a square number, so let's get rid of 35. So now we have x squared minus 12x. These cancel out, and we have a negative 35 over here. Now, if I want this to be a PST, what I have to do, I need a new c here, don't I? So I'm going to take b, divide it by 2, and square it. So b is negative 12 divided by 2 is negative 6, and if I square negative 6, I get 36. So I'm going to add 36 here, And to keep my equation in balance, I have to add 36 here. This is now a PST, so to factor it, it's a binomial squared. Take the square root of x squared, take the sign of the middle term and the square root of 36 squared, and negative 35 plus 36 is positive 1. I need to undo squaring this. I take its square root. What I do to one side, I must do to the other. These cancel out. X minus 6 equals, now the square root of 1 is 1, but don't forget plus or minus 1. Common mistake. Add 6, add 6. X equals positive